All right, let's get started. So again, this is the calendar in case you didn't already know the calendar. Again, I haven't changed anything for the last couple of weeks, so all the assignments that are listed there are still the same current assignments that we're going to be using. Next week, there's going to be a couple different reviews. So I'm going to use the review from the textbook on Monday's lesson. On Wednesday's lesson, I'm going to go over the review worksheet that's going to be posted on Tuesday for you guys to do. If you have questions during the office hours, again, make sure you ask questions. Same thing then for Fridays, there won't really be a need for a live session. I will have it open. Again, I'm talking about next Friday. This Friday, we have no session because, again, there's no school this Friday. But for next Friday, the one where it says test, again, I'll be on here so that you guys can come on and ask questions if you need to. I'm not going to answer test questions. I'll go back and ask any other review questions, things like that. But again, I'll be on here so that you can ask questions that Friday, but it won't be an actual normal live class that Friday. The test will be open from next Thursday through the following Sunday. So it'll be open for 4 days so that you can take it. I have someone in the waiting room. I'm not sure. Let me send a message to them so that they can rename themselves. Okay, I think they might go rename themselves and come back. So again, if you have questions as we go, since I don't have all the features open, please post things in chat as well, and I'll try to go back and answer questions that are in chat, but use the raise hand feature so that I know when you're trying to ask things. All right, let's go ahead and go to the first slide. So again, we are doing 10-5. Now, for this section, again, we are talking about segments in circles and also secant lines. So secant is a new word for us. Now, as far as vocab goes, there's not a whole lot of new vocab in this section, but you will have a few new words. Secant is new to us. Secant is a line, ray, or segment that intersects a circle at 2 points. So it's not a chord because it's not going to be something that stops with both endpoints on the circle. So it has to continue through the circle. So you can have it can be a line, ray, or segment, but if it has both endpoints on the circle, then it's no longer a secant. That would still be a chord. So examples here, line BD and line AC on that figure are both types of secants. Now, there's a couple problems here that we're going to take a look at. So let me minimize this and add somebody else that was waiting. All right, so on this problem here, we have two secants that are intersecting. Now, when two secants intersect, there's going to be a lot of different properties that we can use. So you could use some ideas like vertical angles. You could make triangles out of them. Again, there's going to be a lot of different ideas that you can use when you have chords crossing in a circle or secants crossing in a circle. So there's a couple things on this first question. It says, how can you use arc measures to find the measure of angle 1? Well, if we knew the measure of angle 1, there's actually going to be an equation that we can come up with for this. And this is demonstrating this first example. So I'm actually going to skip past that one. This was in the book. I actually want to come back to that because the properties on the next slide here. When we have two chords or secants that intersect and the angle is inside of a circle, then the measure of an angle formed by two secant lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So essentially it's the average of the two intercepted arcs. So if we look at angle 1, we know angle 1 and the angle that's across from it are vertical angles. Well, those two angles have to have the same measure. Those measures are going to be based on the two arcs that those vertical angles are intersecting. And I don't know if the theorem in the book does a good job of saying that, but again, the two vertical angles are going to be an average of the two arcs that they intercept. So again, each of the vertical angles will be an average of the two arcs that intercept. They write the equation a little bit different than I would write it, but essentially we would say measure of the angle is equal to, I like doing it this way, average of arc 1 plus arc 2. Again, don't have to use the x and y. Again, that's just another way that you can write that. And I'll repeat that for a couple different things. The book uses certain formulas that use variables. Again, sometimes I'll rewrite it so that it's using a little bit more vocab so that it's easier to understand. But again, it's the average of the two intercepted arcs. So let's take a second to go back to that previous page, and now we can try that. So on number 1, it wants to know if arc AD, so we're doing a try it that's over here, if arc AD, so using the same diagram, this arc here is 155 degrees, and measure of arc BC is 61 degrees. What is the measure of angle 1? So angle 1 and its vertical angle across from it are going to be the average of these two intercepted arcs. So we're going to take the 61 plus the 155, add them together, and divide by 2. So if we add 61 plus 155, that gives us 216. And 216 divided by 2 is going to give us 216 divided by 2 is going to give us 108. So the measure of angle 1 is 108. All right, I got a couple other people that added or maybe left and came back. So let me go ahead and add them to the class. All right. If you ever get kicked out and I don't see you or you join late, again, send me a message on Remind. I'll go straight to my phone, so I'll be able to see that message sooner. Again, there's not a way for you to send me a message while in the waiting room. So again, just send me a message through Remind or to my Google Voice number, and I can make sure I get you guys added to the class that way. Okay, let's keep going. So now there's a couple other slides here, or sorry, a couple other theorems on the same slide. So now looking underneath that first theorem that we went over. We have the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measure of the intercepted arcs. So on here, it's kind of the opposite of what we had when it's inside the circle. So on all three of these cases, no matter where the vertex is on the outside of the circle, it doesn't matter if we have two secants, if we have a secant and a tangent, or if we have two tangents. As long as the angle's on the outside of the circle, it's going to be the difference of the two arcs and then divide by 2. So I'm going to write this the same way I did the other angle. And essentially the only thing that's going to change is the sign's going to change to a subtraction symbol. And instead of writing arc 1 and arc 2, there's going to be an important difference here because there's always going to be two different size arcs when you have this happening. So I'm going to write big arc minus little arc. So I'm going to say measure of the angle will equal the big arc minus the little arc divided by 2. So this kind of sums up the idea of all three of these cases that are here at the bottom. So in the first one, we have B is the big arc, A is the little arc. So it would be B minus A divided by 2 gives you angle 1. On this one, D minus C divided by 2 would give you 2, angle 2. Case 3, if we took F and subtracted E, then we'd have F minus E divided by 2 gives us angle 3. All right, so let's look at a couple of examples for these. So now we have what is measure of angle ABD. So ABD is going to be, again, we're looking at this angle that's outside the circle. So this angle right here, we're going to take, this is the bigger arc that's intercepting, and this is the smaller arc that's intercepting. Well, in this case, we don't know the little arc. So there's one step that we're going to have to do first. An entire circle adds up to 360 degrees. So if I take the 360, subtract the two angles that we know, that'll leave us with the one arc that we don't know. So 360 minus 151 minus 139 gives us 70. So for this arc, that's going to be 70 degrees. So now that we know this, we're going to take the big arc, which is the 151, minus the smaller arc. Again, these are the two intercepted arcs, and then divide by 2. So we have 151 minus 70 divided by 2 is 40.5. So we have our final measure for that angle is going to be 40.5 degrees. All right. On the next one, B. Oh, hold on, my chat box disappeared. Let me bring that back up just so I can see. Somebody sent me something. Oh no, it's just a here message. All right, let me keep going then. So on B, we have 2 arcs. This time we have 2 secant lines. Again, the last one was a secant and a tangent. Now we have 2 secants, but it's still the same idea. We have a big arc, which is going to be this piece, and we have a little arc that's going to be this piece. But now it's algebraic. It's still the same rules. They gave us the angle measure this time, so we're going to plug it in like it's an equation and then find the measure of arc, LM. So we have the angle is 34 degrees, and we know that the angle is going to be equal to the big arc, which in this case was 6x plus 6, minus the little arc, which is 3x minus 5, and then divided by 2. So the difference of big arc minus little arc divided by 2. Now, we can go ahead and combine like terms here. When you do the subtraction, you got to make sure you distribute that negative sign to both. So this negative sign will get distributed and becomes minus a -3 and a +5, that we can turn this to a plus. Actually, let me go back and do that with a different color so that you can see when you go back and look at notes. Let me erase that part. Oh, I'm using different tools. Let me try using the annotate tools. That is not going to work. So again, just writing this in a different color. Let's do blue. So again, I'm changing the sign to a plus, changing the sign to a negative, and then I can change this sign to a plus because I took the negative and I distributed to all the parts. So now that we've done that, now we can combine like terms. So we have our 6x and our 3x gives us, oops, sorry, that was a minus now, so that should be 3x. And then when we have 6 and 5, and again, both are positive, so it's going to be 11. And again, still over 2. And we have 34 over here on this side. Now, we can do a couple different things with the 2. We're solving for x, so you could either decide to divide both top numbers by 2, but since they're both odd, I'd advise against that. I go ahead and just get rid of the 2 by multiplying it to the other side. So we're going to multiply 2 to both sides, times 2, times 2. On this side, they cancel out. So now we're going to have 68 on this side. And up top, we now have 3x plus 11. We're going to subtract off the 11. So we're left with 57 equals 3x. And then 57 divided by 3 is a whole number of 19. And that's x. Now, was that the answer to our question? Well, they want LM. So we got to go back for LM, which is this big arc over here. We got to plug it in. So 6 times 19 plus 6. 6 times 19 plus 6 is 120. So for this one, our answer is 120. Make sure that's none of you guys texting me. No. Did she get it in? That was a while ago. I think so. Let me just check the list and make sure that she's in here. Yep. All right. We're good. All right. So now for the other problems down there at the bottom, we have for try number 3. Let me change my pen. Don't let me. So here, again, we're setting this up slightly different. We have an intersection inside. So we know that these two angles are going to be an average of the two intercepted arcs. Well, they already told us this is 107. So again, these two are the same. So on this one, remember, the measure of the angle is equal to the sum of arc 1 plus the sum, plus arc 2 divided by 2. So we have the 74. We don't have this one, so I'm going to call that x. So we know the angle measure is 107. We know that one of the arcs is 74. We're missing the other arc, so that will be x, and put it over 2. So we can take the 2, multiply it over to the other side. That will give us 214. So now 214 equals 74 plus x. Subtract off the 74. So 214 minus 74 leaves us with 140. So this arc over here will be 240 degrees. And that's our answer. All right, on part B. So this one wants us to find measure of angle PSQ. So it's this angle that's outside the circle. So now we're back doing the difference. So we need to do the big arc minus the little arc. Well, we have the measure of this big arc, but we don't have the measure of the little arc over here. So same way we did the previous problem, subtract the 2 that we know from 360. So 360 minus 152. So a little bit of lag there. 152 minus 126. So 360 minus 152 minus 126 equals 82. So this arc over here is 82. So now for the angle, big arc, 152 minus little arc divided by 2. So 152 minus 82 divided by 2. So that's 70 over 2, which is 35. So this angle here is 35 degrees. All right. Let me pause for a second, see if there's any questions at this point before I continue on. I know that there's quite a bit in this section, so I don't see any hands. Is there anybody that has a question before I move on to the next set of examples? All right, Jade, let me unmute you so you can ask your question. All right, Jade, you're unmuted.
Yes, so in activity number 8, when you did the signs change.
So you're talking about right here in the middle of the screen?
Can you please explain it, because I got confused. Why did you change for positive and then negative?
So again, since this was we're doing the difference, right? Since the angle is on the outside of the circle, it's going to be the difference divided by 2. So this was originally a subtraction sign. Whenever you have a subtraction sign, since we have parentheses here, we're going to have to distribute it to both parts. So if I had, let me just show part of that equation for a second. So I'm just going to write this one little piece. So we had minus the 3x minus 5, like this, right? That was the back half of that equation. Well, we're taking this negative, and that negative has to be distributed to both of these. So when you distribute it to both of those, that negative that was there on front is no longer there because it's part of the 3x and it's part of the 5. So it becomes an addition sign when you get rid of the parentheses. Does that make sense? Okay. All right. Ted, 3-point question mark. I'm not sure what you're trying to say, so let me go and mute you. All right, Ted, you're unmuted. Do you have a question? Ted, are you able to talk? Hello, Ted. I'm not hearing anything. Can you type your question? I don't know if we lost Ted there. All right, was there anybody else that had a question? Okay, so let me go ahead and I'm going to keep going here. So on to the next slide. We now have what is the value of x? So on this diagram, the red lines wouldn't normally be there. So this is an example question. Everything that's in black is what's there to start the problem. And then they're giving us those measurements that are in red. But again, the other red lines wouldn't be there to start off. What they're trying to show us is if we were to draw in those lines, we could then make 2 congruent triangles. Or sorry, not 2 congruent, 2 similar triangles. Because if you had drawn this line, these 2 dotted lines in, angle B and angle A both intersect arc CD, making them congruent. And then you have angle C and angle D both intersect arc AB, making them congruent. So now we have 3 angles that are the same. Again, you could use these 2 are vertical angles. You could call this AA similarity and say the 2 triangles are similar. Once you know the triangles are similar, you can set up a proportion to solve this question. Now, there is a shortcut to doing this that you don't have to do a proportion every time. There's actually an equation for this. But for this first question, again, you could set up the proportion. These 2 sides are related. So I'm going to do the small triangle 4/6 is equal to the small triangle to big triangle 5/x, because those are the sides that are relating to each other. Now, what would we do? We'd cross multiply and solve. So 4 times x is equal to 6 times 5. 6 times 5 is going to give us 30. And then 30 divided by 4 is going to give us 7.5. So on this question, again, we're able to do this with a proportion, but there's an equation that we can set up on here because you know how we cross multiplied and got to this step is, again, we had multiplied these 2 together and these 2 together. Well, you'd be doing that same proportion every time. So you'd be doing that same cross multiplying every time. So notice how the 4 and the x in this step are on the same line, and the 6 and the 5 are on the same line segment. That's basically our equation. We can take the 2 parts of the same line segment, multiply them together, and the 2 parts of the other line segment and multiply them together. So look at the next slide. Now, we only did the example for case 1 here. So case 1, it shows we have A and B on the same line, C and D on the same line. So we're going to do A times B is equal to C times D. So the two parts of the same line is equal to the two parts of the other line. Now we didn't prove cases 2 and 3, but there's a formula here as well. And the way they write it out, I don't really like doing it that way. Like I said earlier, there's some formulas that they write that I disagree with. So I usually always do case 1 the same way that they did there. But for case 2 and 3, I do this slightly different. In case 2, we have two secants. So we're going to have, they're meeting at a common point. And then I normally label this as, instead of M and N, I'd call this part the exterior, the interior, and the whole. Now, this piece, again, is the exterior. This is the interior. And then we have the whole. And since we have two different lines here, we have two different exteriors because these do not have to be the same length. So this will be exterior 1, interior 1, and whole 1. This will be exterior 2, interior 2, and whole 2. So the way that I normally write this equation is the exterior times, so I'm going to go exterior 1 times the whole 1 is equal to exterior 2 times the whole 2, which if you look at what they have, that's what they did, just all with variables. So they have exterior was n, the whole would be m plus n. And that's what they multiplied here. They have n is the exterior, and m plus n, that's the whole. Same thing over here. Q is on the exterior, Q, and then P plus Q, that's the whole. So again, they're multiplying the same things as how I set up that equation. It's just this is using words instead of variables, so it's a little less confusing, I think, if you put that in terms of what you're multiplying each time. Same thing goes over here with the tangent and the secant. Essentially, you are using the same exact equation, but the exterior piece here, or the tangent, is the same as the whole. They're equal to each other. So instead of just calling this exterior and whole, we can just call it the tangent. So we have the tangent piece, so that if you were to plug into the other equation that we had on the previous problem, you could say, again, instead of exterior times whole, well, if I'm doing exterior times the whole, and these are both tangent, then that'd just be tangent squared. So the actual equation that I like to use for this problem, if we have a tangent and a secant, tangent squared equals exterior times the whole. So we have the tangent for this piece, right? This piece I'm calling tangent. I'm no longer calling it exterior. And then on this side, I have the exterior and the whole. So that way I'm only dealing with one exterior and whole. But again, it's the same idea as the previous problem, just set up a little differently because the tangent is both the exterior and the whole in that case. Now, we can use these on these problems down here. So the first one is inside the circle. So it's simply, we have the two parts that are on the same line, 10 times y equal to 7 times 15, because those are the two parts on the other one. So then we take the 7 times 15, and 7 times 15 is going to give us, once I hit divide, 7 times 15 is going to give us 105. And then if we divide by 10, that's just going to move the decimal place. So it's going to be 10.5 for the length of part y. Now, on the middle one, we have what is the value of a. So this one has a tangent and then a secant. So for the tangent, it's going to be the tangent part squared equals the exterior, which is a, times the whole, which is going to be both of these together. So it's going to be a plus 9. So sometimes we're still going to have to do the parentheses like they did. So a plus 9 And this gets a little messy because now we have 36 equals, this is going to be a squared plus 9a. And unfortunately, we have a quadratic now. So this one's not the nicest problem. I probably won't ask you any quadratics on the test. However, I'm going to go ahead and do this one real fast because next year, you guys will be back in Algebra 2, and you guys are going to have to be doing some factoring again. So I'm just going to remind you guys of some of your factoring skills. On this one, there is a shortcut, and essentially what we're going to be looking at, since we have a lead coefficient of 1, we can just look at the last term, figure out factors of the last term that add up to the middle number. Now, I will not give you this on a test. The other thing is you could also do completing the square for this. That would be, again, something that we did this year. So if you want to complete the square, you could do that option. Actually, let's go back and do that option because something that we did this year, and I can just show you how to use it for this question. Because that equation that I have there was not a perfect square. So let's make it a perfect square like we did earlier this year. And I can show you how to use that to solve instead. So let's do, for this side, I'm going to have to add something. So if I take the value of 9, 9 divided by 2 and then squared, well, 9 divided by 2 is going to be 4.5. 4.5 squared is, now I know this looks messy at first, but it's going to be 20.25. So add that same 20.25 to the other side. So 20.25, add that to 36, and we have 56.25. Well, again, we are going to take the square of the first term, which is a, square of the last term, which brings us back to where we started off, the 4.5. Sign from the middle, positive. So we have our binomial. On this side, we still have that, what was that, 56.25. The lag in this pen is driving me crazy. So solve this, take the square root. So that's 7.5 equals a plus 4.5. Subtract off the 4.5, and you get 3. So that's kind of hard to see. I'm at the bottom of the screen. So that down there is what I got. Again, I know that's a little difficult. I'm not going to give you guys one that's hard. Don't we have to subtract? No, so again, remember, when you are balancing the equation on completing the square, you have to make sure that you're doing the same operation to both sides. So I wasn't getting rid of the 36 from this side like I had originally started doing. I was trying to make this side a perfect square, and the number that you're adding over here will always be a positive number. So you have to add that same positive number to the other side so that we balance the equation. So again, we added the the 20.25 to both sides. So that was correct, adding, not subtracting. Oh, Ted came back and asked a question about the previous page. I'll go back to that page in just a moment. Let me finish part B here, and then we can go back. So for part B, we have, what is EC? Well, now this is a much easier question. Again, this one is inside this circle. I'm going to go ahead and call this X. We're just going to do 4 times X equals 5 times 8. So we get 4X equals 5 times 8 is 40, divided by 4, and x is 10. And that's our answer. All right, let me go back for Ted there. We had, what was it, for 3A, how did we get 140? Let me take a look back at that previous page. Oh, went too far. This one, right? So for the 140, again, that last step, we subtracted off the 74 because we had, the equation was 107 equals 74 plus x over 2. First, we got rid of the 2 by multiplying it to the other side. That gave us the 214. Then got rid of the 74 by subtracting it, and that gave us the 140. All right, were there any other questions I had missed? Let me go back to the page we were on. Any other questions on this page? All right. Well, let's go to the next. So this is a summary, again, of all the properties that we did. Again, the summary from the book doesn't write the equations quite the way I write them. I'm going to rewrite these real fast over top of them. If you like the way that the equations are written in the book, great. If not, again, I'm going to go ahead and write them the way that I always write these. So the measure of the angle is equal to arc 1 plus arc 2 over 2. Again, the idea there is that these two angles are the same because they're vertical angles. So those two angles will share the same measure, and the way you find each of those is by taking the average of their two intercepted arcs and dividing by 2. When it's outside the circle, it's kind of the same formula, except you're doing the difference. So there'll always be one that has a bigger measure. So it's going to be the big arc minus the little arc divided by 2. For segments inside the circle, again, you're taking the two parts, multiplying them together. So 2 parts from the same times 2 parts from the same. All right. And then on the other ones, again, same idea. I'm going to relabel these same way that I labeled the other ones. So we have the exterior, and I'm not going to go ahead and label interior this time because we don't really have to use interior at all. It's just I labeled, oops, I'm saying interior, I'm writing interior. So exterior and the whole, we didn't have to really use the interior piece in the equation. That's just for when we're talking about it, that's what I would consider the interior. So this would be exterior 1, this would be whole 1. This would be exterior 2, and this will be whole 2. So the way that I write this is the exterior 1 times, now I still like writing parentheses around the whole because sometimes you're going to have to write more than one thing added together. And then exterior 2 times whole 2. And for the other one, since, again, it's the same equation, but since this piece is the tangent, I'm going to go ahead and write tangent. Let's change this color so that I'm not overlapping the color too much there. So we have, let's use red. No, they have red on the diagram. Let's use blue. So this piece is going to be tangent. This is the exterior. And then again, whole. So we have tangent squared equals exterior times whole. All right. So that's a summary of all the equations that we're using in this section. Were there any questions? So what was the equation for theorem 10-11? I think one of those is what's on the screen actually. So this is them also. I'm definitely going to go back and see what 10-11 was. I have my book right here, so I don't have to change the screen. 10-11. So yeah, so 1011 is this one right here, the one that talks about the vertex on the outside of the circle. So measure of the angle is equal to the big arc minus the little arc divided by 2. Yes, I'll post these notes on Edsby after we're done here today, and I'll also post the video. We are right at 45 minutes. I don't normally like going past that, so let me quickly show the other slide. Again, these were just extra examples if we had time for them, but this is kind of the same thing that we've already done. And then here's the assignment from the textbook. So again, for tomorrow's assignment, it's from the textbook again. The page is already posted. I think I've already attached it as well on Edsby. I'll have to double check that, but it is already posted in the folder that's on the OneDrive. And then again, it's just problems 16 through 22. So out of this whole page, you're just doing the practice. And 16 through 22, notice you're not doing anything that says prove, because we're trying to stay away from the proofs. Oh, cancel that. I missed one. And I missed 2. All right, get rid of those. I don't want you to prove those. So skip 18 and 19. So not a whole lot. Is there anything over here that we can do in place of it? You know, these 3 questions here would be a good practice. So I'd say you might want to try these 3 questions in place of those other 2. So I'm going to write on here number 12 through 14 because I don't want you guys doing proofs. Okay, any other questions? If there's no other questions, that's it for today. Again, I'll be back on tomorrow. Again, the hours for my office hours are the same as what they were on Tuesday. That'll be the same hours from now on. So that 12:45 until 2:15, that'll be every Tuesday and every Thursday. So again, come back on tomorrow if you have questions. Next week, we'll be doing a lot of review stuff. So again, Mondays will be the review from the textbook. We'll go through the entire review in the textbook. If you want to try that review first, I'll have it posted probably sometime tomorrow. But again, it's the review at the end of the chapter. I'm going to go through that entire thing. So if you want to try doing that review first, you can. And then on Tuesday, the other review for our test will be posted. And on Wednesday, I'll be going over that review. If you have other questions, though, next Tuesday and Thursday, I'll be glad to go back over anything that you had questions on. And any other questions currently? I already saw quite a few people leave. No, we're good. Don't see any hands, no questions. All right, I'm going to go ahead and end this and then save and post this to YouTube and Edsby. All right, have a good day.